Hello everyone, my name is Kunal and I'm your physics tutor and we're actually doing ray optics and today is our sixth lecture on this topic. So let me quickly recap the things कि हमने previous classes में क्या क्या चीजें cover करी थी. So in previous classes we actually deal with like velocity of object, image with respect to mirror, actually plane mirror and ground, right? So हमने कुछ कुछ relations निकाला था. One like parallel to the mirror and other will be like perpendicular to the mirror, right? So ये सारी चीजें कुछ कुछ हमने derive करी थी. Now in and हमने फिर spherical mirror पे हमने बात करी थी. Spherical mirror like हमने इसमें दो तरह के बताया था. एक होती है concave, the second one is convex, right? जिसमें हमने कुछ कुछ टॉपिक बातें करी थी like marginal rays, पैराक्सियल रेज. जिसमें हमने बात करी थी मार्जिनल रेज क्या होती है, which actually a ray striking near the pole is actually paraxial rays, जिसमें angle of incidence less than 4 degree होती है. And marginal ray, if the ray is striking away from the pole is actually called as marginal ray, जिसमें angle of incidence greater than 4 degree होती है, right? So ये सारी चीजें हमने बात करी थी. And मैंने ये भी कहा था कि we are in this chapter we are only deriving the formula for paraxial ray, which is actually angle of incidence is less than 4 degree. Then हमने कल एक चीज और बात करी थी which is actually termed as focus और focal length, जिसमें हमने ऐसा बात करा था कि point on the principal axis at which parallel and the paraxial ray intersect or appear to intersect is actually termed as focus of the spherical mirror. जैसे हमने ऐसा बात करा था कि this is actually our, let us suppose that concave mirror. This is actually our principal axis, and from there a ray of light which is actually parallel and paraxial to the principal axis and intersect the principal axis at some point which is actually called as focus. And the distance of the focus to pole is actually termed as focal length. राइट. सो ये सारी चीजें हमने कल उस प्रीवियस क्लास में कवर करी थी. एंड हमने एक रिलेशन लिखा था फोकस इज इक्वल टू r by 2 where r is actually nothing but this is actually our center of curvature. So the distance of center of curvature to the pole is actually termed as radius and the focus is actually is equal to r by 2. So हमने ये सारी चीजें और मैं एक ये रिलेशन लिखा था which is actually f is equal to r by 2. So now in today's class, in today's class, we are gonna first derive about like how the formula f is equal to r by 2 come, right? So let's start solving. So we are, I'm again telling you, we are whatever formula we derive here is actually based on for paraxial ray only, right? So let's start. Let's prove this thing. We are gonna actually prove f is equal to r by 2, and we actually also derive for the marginal ray. So you can also look at it. So what I'm trying to say, I'm gonna draw. Let us suppose I'm taking a spherical mirror as concave mirror, and this is actually our principal axis. This is actually our pole. And this is actually, let us suppose this is actually our parallel ray of light and it is actually passing through the focus F, and this is actually our center of curvature C, and let us draw this. So actually there is a reflection happening, so this angle of incidence is actually equal to angle of reflection, as we discussed in our first or second lecture, that the laws of reflection is valid everywhere. Either the surface is smooth or plane, or the surface is curved or rough or whatever. The laws of reflection is valid everywhere. So here the angle of incidence is actually equal to angle of reflection. And so this angle is also theta, right? Because this and this, because this ray is actually parallel to the principal axis. So alternate interior angle would be same. So this angle is also theta. And let us assume this distance, the distance of center, actually the distance of the center from the pole is r. Okay, so let's start solving, right? So what is this angle? This angle is nothing but pi minus 2 theta. Why? Because the sum of all angle of triangle is actually equal to pi. So let's start solving. So what we can write here, if I'm going to write sine of pi minus 2 theta by r is actually is equal to sine theta by x, right? I'm assuming that this distance is actually x, right? So we can write now sine of pi minus 2 theta is equal to sine minus, basically I am applying the sine rule here, right? I hope you all know the sine rule and cosine rule. Like sine of a by a is equal to sine of b by angle b by b is equal to sine of c by angle c, right? So this is the thing we are actually applying here. Now the next thing we can write it here as sine of 2 theta, because by r is equal to sine of theta by s. And one more thing we're gonna write here, the sine 2 theta formula will be 2 sine theta cos theta by r is actually is equal to sine theta by x. So here the sine theta get cancelled, and we get 2 cos theta by r is actually is equal to 1 by x. So here we get x is equal to basically 1 by x is equal to, or x is equal to, we can say r by 2 cos theta. Now this is actually our focal distance, right? Which is actually I'm representing by f. So here we can say f is equal to r minus x. So here like r minus r by 2 cos theta. So here we can write r is equal to 1 minus 1 by 2 cos theta. So this is actually our focal length for marginal rate. Now I'm gonna derive, and I'm earlier told you like the all of the formula that we derived is actually we derived for what? We actually derive it for the paraxial rate. Right. So in that case, when we derive the formula for the paraxial ray, so it will be actually we have to use an approximation. So let me write it here for paraxial ray. We all know that the angle of incidence, which is actually here theta, is actually less than 4 degrees. So in that case, cos theta is equal to 1. So what I'm going to write here, f is equal to r1 minus 1 by 2, and cos theta is equal to 1. So here we will get as f is equal to r by 2. I hope this thing will be clear to all of you, and this gate actually proved. Right. I hope this problem is actually clear to all of you what I'm trying to say. Right. So the just thing, so the things what I'm trying to say is, you have like in previous class I just write the an equation like focal length is actually the half of the distance or half of the radius of curvature, right? But you have to prove this thing. So what I'm going to take it as, I'm just taking a concave mirror. You can also take the convex mirror as well, right? And then what I do here is, I just take the sine rule, which is actually like sine A by A is equal to sine B by B is equal to sine C by C. And then what I'm doing, I'm just taking the uh, I'm finding x, and which is actually the distance between f and c. But we have to find the focal length, which is actually the distance between the pole and the focus. So it will be like r minus of x. So when you do so, it will be like r minus r by 2 cos theta. And when we get r, when we take the r as a common, so we get r into 1 minus 1 by 2 cos theta. Right. When we get so, and when we apply for the paraxial ray, for paraxial ray, the angle of incidence is actually less than 4 degree, right? When the angle of incidence is actually less than 4 degree, so the cos theta value, so the cos theta value is nothing but, right? So the cos theta value is actually nothing but uh, r by 2. And actually the cos theta value is actually 1. So uh, we can write it here like r is equal to r into 1 minus 1 by 2 cos theta. And so we will get as F is equal to R by 2, right? And hence it's proved. I hope this will be clear to all of you, right? So we can do one more thing here, like we derive this thing, and let's move to the our next topic, which is actually termed as sign convention. Okay, so please give me a moment. Wait. Okay, so now let's move to the sign convention, right? So our new topic is nothing but sign convention. So actually, the sign convention is the thing that actually more than ये थोड़ा सा confusing topic है, right? So it's like a confusing topic, and so but मैं आपको सीधा सीधा एक रूल बताऊंगा जिससे चीजें आसान हो जाएंगी, है ना? So don't worry about that. So let start it here. So I'm just gonna write a line which is actually applied to every, because this topic is actually try to more and more its implementation in solving what I'm called it numericals, right? So now take origin as pole of mirror. What I'm trying to say, just listen, because this is actually sometimes confusing to students. So yeah, you have to keep this thing in mind. Take positive direction along the direction of considered, right? So what I'm trying to say is the first thing you have to do, take origin as pole, okay, and take the positive direction along the direction of considered ray. So what I'm trying to say, look at here, like let us assume this is actually our concave mirror. You can take it anything like convex mirror as well. What I'm trying to say, let us suppose our ray is actually going from negative x to positive x, right? So and this is actually our y, and I'm assuming this has pole, origin as pole. So this is our y axis. So we are defining some of things like, let me write it here. Some of like the term using here, this is actually U, V, F, R. Okay. So these are the term actually using here. And I'm going to write what it represents. So actually U represent the distance of image from, distance of object from pole. And we represent the distance of image from pole, and F, you all know the distance of focus from pole. So actually we can assume pole as a origin, right? So we can assume pole as a origin, and you all know that a distance of center of curvature from pole. Some more abbreviation is used here, so let me write it here. This is actually also like we called as YO or HO, YI or HI. So this actually represents the height of object, or you can say like size of object. And the second thing is like height of image, or you can say size of, right? Now you have to find these direction like positive or negative, right? So these are the things that you have to know. So now let's take the first, we are gonna talk about like convex mirror, right? So let's start talk about the convex mirror. First part is convex mirror sign conventions, right? We are actually dealing with the sign convention of the convex mirror. So, or you can take it as concave as well. So I think I have to derive for the both of the mirror. Concave mirror also, right? Leave it as. तो मैं दोनों मिरर के लिए बता दूंगा आपको. Don't worry about that. Okay. So what I am taking the case one, like let us suppose this is actually our concave mirror. I'm gonna write for convex mirror as well. So okay, so don't worry about that. I am assuming the origin as a pole, and I am assuming that the object is actually placed in front of the mirror. Okay. So what is actually going to happen? Like I'm assuming that this is actually so this is the actually distance u, and there is actually image formation. This is actually I, and this is actually v. So what is u? The distance of pole, the distance of object from pole, and what is v? The distance of image from pole, right? Now, the thing is, I'm again telling you, you have to uh, take the positive in which the ray is actually going. ठीक है. और you जो मैंने यहाँ पे concept लिखा है, take the positive direction along the direction of the considered ray. So let us assume here the ray is actually going in this direction, right? The ray is actually going in this direction, and our distance is actually in this direction. So here u is actually negative, and v is also negative, and f is also negative. Why I'm trying to say this? Because our ray of light, the incident ray of light is going in positive x direction, and we are taking the distance in negative x direction, right? In this direction. From pole, the object is placed in leftward direction, so it will be termed as negative. And v is also negative, f is also negative, right? Now let's take the case 2 here. Again for the concave mirror, so it will be, let us suppose there is the object, and oh, okay, and there is the object, and this time actually ray of light is reflected in this direction, and it's like appear to meet in the backward direction. So this is actually I. Now this time again the ray of light is going from negative x to positive x direction, and this is actually our u, and this is actually our v. So here and somewhere this there is f, you can say. So here u is also negative, f is negative, but our v, which is the distance of image from pole, is actually in the direction of considered ray or the direction of the incident ray, right? So this actually in the from pole, it is actually the distance will be in this direction, so it will be treated as positive, right? So now let's talk it about now. I can say for convex mirror, right? So for convex mirror, let me draw it here. So for convex mirror, it is something look like this. And let us suppose there is actually our object. So ray of light is going in this direction, after reflection going in this direction, and it is actually appear to meet here. So this is actually our image. So again, you can say u is actually our negative because our ray of light is going from negative to positive direction, but actually the curvature in this direction, so focus is in the rightward direction. So here f is actually positive, and v is actually also positive because it's actually lies in the direction of incident ray, right? So these are the sign conventions that you have to keep in. The second thing you can say here is, let us suppose this is the case A, and exactly the case B, and exactly our convex mirror. And let us suppose this time the object is virtual. That means if object is not placed in front of mirror, but is inside the mirror, like virtual object. Okay. And this time what is happening? The ray of light is like appear to meet here, right? And then what happened after reflection? The ray of light is somewhere like going in this way, going in this way. So it will be like appear to meet on the uh, back end side. This is actually our object. This is actually our image. So in this case, the U is also positive, V is also positive, and F is also positive, right? So you can say here like incident ray are convergent and reflected ray are divergent. So let me quickly summarize you about the sign conventions, right? So look at here. Uh, like यहाँ पे पहले कुछ तो terms define है like U, V. First I'm gonna tell you like F, R जो आपको previous class से पता होगा. But कुछ और terms यहाँ पे आके add हो जाती हैं जिनमें से पहला term add हो रहा है U. So what is U actually? So U is actually the distance of the object from pole. Okay. And then V is actually used to represent distance of image from pole. F you all familiar with, which is actually the distance of focus from pole. And R you guys already familiar with, which is actually a distance of center of curvature from pole. And the new term, which is actually is YO or HO, which is actually represent the height of the object, and YI and HI, which actually represent the height of the image. Now let's talk about the sign convention. इनमें से ऑब्जेक्ट कहाँ होंगी तो साइन कन्वेंशन क्या लेनी है नहीं लेनी है. The things you have to keep in mind, which is actually this is actually a one line concept, क्योंकि बहुत सारे बुक में ये क्लियर नहीं मिलती है, डायरेक्टली यूज किया करा जाता है, तो इट विल बी लाइक समटाइम्स कनेक्ट करने में प्रॉब्लम हो जाती है, बट इट्स लाइक अ वन लाइन इजी कॉन्सेप्ट. व्हाट आई एम राइटिंग हियर इज the things you have to take the pole as an or basically origin, and considered or take the positive direction along the direction of considered rays, right? I hope it will be clear and understanding to all of you. Okay, so you have to just take the positive direction along the direction of considered ray, and then what you have to do, just you have to write according to the following. So first case I'm considering about the concave mirror in which the object is actually real because it actually kept in front of the mirror, right? The object or basically O represents the object. So let me write it here also. I hope you all guys know what this, and I represent the image. Okay, so O represent the object and the I represent the image. So what I'm trying to say is here the object is actually placed in front of mirror. And I'm assuming that the image is also real because it's also forming in the front of it. So what I'm trying to say is here the ray of incident light is actually traveling from negative x to positive x. Basically, I'm not saying like that it travels from negative x to positive x because it's actually traveling in the right direction. That is the word we can say. But the distance we measure from pole to object is actually in the left direction, right? The object is actually placed in the left direction. So the direction is opposite, and we already read in the concept of the sign convention that we have to take the positive direction in direction of incident ray, right? But here the incident ray is in rightward direction and object is actually placed in negative direction from the pole, so it will be treated as negative. And all and image also lies in leftward to the or the opposite direction to the what I'm trying to say opposite direction to the considered ray, right? So so here again we have to assume that the distance or the sign as negative, and focus is also lying the left to the also focus is also negative. In second case, what I'm assuming, in second case, I'm assuming that our image is this time virtual image and the object is again real because it's actually placed in front of mirror. So in this case, the ray of light, the ray of incident light is actually again travel from left to right, right? The image is actually travel from left to right. So when it travel from left to right and the object is placed with respect to pole in leftward direction. So, so the U is actually treated as negative, but the image is actually forming in the direction of incident, right? Incident ray, because the incident ray is traveling the rightward direction, and image is also formed with respect to pole in rightward direction. So, V is actually taken as positive. Now, let's talk it about the convex mirror. So in this case, we are actually assuming the virtual object, or basically real object, and the image is actually forming in the virtual. So in first case, the image is actually virtual. So the same case as like for the upper one. And in the second case, what I'm assuming, I am assuming that basically I'm assuming that this time the object is virtual. Okay, this time object is actually virtual. So when the object is actually virtual, so what I'm trying to do here is, and image is also virtual. So actually the both of the object and image is lying in the direction of incident ray, which is actually in the rightward direction. So so I'm going to take the both of the U, V, and F as a positive sign. And one more thing that we notice here is like that the incident ray are convergent, right? And the reflected ray is actually divergent. So this is the thing that we actually conclude. Now we are gonna learn the new concept, which is actually termed as a mirror formula. This is actually very much important for problem solving or numerical solving aspect. So the mirror formula is actually, this is written as 1 by F. Again, whatever we are explaining or deriving the formula in this chapter, all for the paraxial ray. That means we are assuming that the angle of incidence is actually less than 4 degrees. So it is actually 1 by F is equal to 1 by U plus 1 by V. And you have to follow the sign convention according to the questions. Right. And this is actually equal to 2 by R, because F is equal to R by 2. We derived here for paraxial ray, right? F is equal to R by 2, right? We already derived this thing. So 1 by F, we can write it as 2 by R. So this is actually our mirror formula. We are going to derive it as well. So let's derive it. I'm actually deriving it for concave mirror. You can derive it with the same aspect for the convex mirror as well. Right. So let's start deriving. Okay. So derivation. So let me draw the figure with some different color. Let's take a red one. So I'm assuming that this is actually our concave mirror. This is actually our pole. And there is actually our object, which is actually in front of mirror, right? And I'm assuming that the image is also formed in front of mirror. So there the ray is actually going on. Okay, let me make a big figure. Otherwise, it become very tough to understand. So let me make a big figure here. The thing is, we can't take the semicircle, so that's why I have to struggle here. Okay, let me try again. Yeah, that's fine. That's fine. Yeah, that's fine, I think. Okay, so this is actually our concave mirror. I'm assuming that there is my actually object, and this is actually rays going, and I'm assuming that the center is at the right hand side, and the ray of light is actually this way. So there is actually our image, and let's take a line from center, which actually joining the, okay, and this point is actually our center of curvature. So I'm assuming that this angle is alpha, right? And this angle is actually beta, and this angle is actually gamma, and there is actually a reflection occurring. So angle of incidence is equal to angle of reflection. So I'm assuming that both angle will be theta. Now let's giving me this point name as A, and I'm assuming that from principal axis, the distance of point of reflection is actually H. I'm assuming that, okay. And this is actually our pole. So the things I assuming that we have an object, we have a real object and the real image, And I'm assuming that the angle between incident ray and the principal axis is alpha. The angle between the line joining center and the point of reflection from the principal axis is beta. And the line joining and the angle between the line joining the image and the point of reflection and the principal axis is actually termed as gamma. And the distance between and the distance of point of reflection from principal axis I am termed as at a height h. So from property of triangle, let me use some different color to write the proof. Okay, so from property of triangle, okay, we all know that the exterior angle is actually equal to the sum of the interior angle. So we can here we can write alpha plus theta is equal to beta. This is actually first equation. Beta is equal to sum of opposite two interior angles. So it will be alpha plus theta. Similarly, gamma is actually is equal to beta plus theta. So gamma is actually is equal to beta plus theta. This is actually equation 2. Now what you have to do, you have to just add the equation 1 and 2. So what you get when you add the equation 1 and 2, or we can say, wait, subtract the equation. So this theta theta get cancelled, so we get a relation here. Sorry, it's my bad. Okay. So what I'm trying to do, subtract 1 and 2. So what we'll get from here is alpha minus beta is actually equal to beta minus gamma. So here we'll get alpha plus gamma is equal to 2 beta. Right. What we will get? We'll get alpha plus gamma is equal to 2 beta. Now let's start uh, let's start writing the some of the tan of the angle, right? So when we write the tan of alpha in this triangle, if I'm assuming as of this triangle, so this height is actually h. So tan of alpha is p by v. So it is actually, I'm assuming that it's near the pole. So I'm considering the whole distance, right? So I'm considering that tan of alpha is actually nothing but h by the distance of object from the pole. I'm considering for the paraxial ray where the reflected ray is near to the pole. So I'm this distance is actually very negligible. Not negligible, it's very most negligible. Okay. So what I'm trying to say, the tan of alpha is actually h by u, where u is the distance of object from the pole. And the next thing is actually tan of beta. So tan of beta will be, look at here. So the tan of beta will be actually h by r, because r is the distance of center of curvature from the pole. So it will be actually equal to h by r. And the third thing is tan of gamma. It is actually equal to v by, h by v. H by v, the distance of image from pole is actually v and the height h. P by v. Okay. Now, look at here. As we are considering for paraxial ray, so we all know that when alpha, beta, gamma is very much less, so tan of alpha is equal to alpha, tan of beta is equal to beta, and tan of gamma is equal to gamma. Right. We all learn these kind of approximation. We all learn this kind of approximation in trigonometry identities, right? So, okay. I hope you all guys are familiar with. Now we reached to a relation where actually alpha plus gamma is equal to 2 beta. So let's from equation 3 where alpha plus gamma is actually equal to 2 beta. Where actually alpha we can say h by u, gamma you can say h by v, and 2 h by r you can say h beta. So take h common from both sides, or you can eliminate directly from both sides. So what we'll get? We'll get 1 by u plus 1 by v is equal to 2 by r, right? And we all know the r by 2 is actually f. So we can say here like 1 by u plus 1 by v is equal to 1 by f. Similarly, from there you can say V is equal to UF by U minus. I'm just writing it to the in form of V only. So I'm actually writing the V in terms of U and F only. So it will be like V is equal to UF by U minus. But one more thing you have to notice here is you have to follow proper sign convention, because there is a small error in sign convention lead to the different answer to your problem, right? So it's a very kind of sensitive things. So I'm again telling you, use sign convention in correct way, right? Because let us suppose you are considering like plus to minus. So everything will be changes, right? Like nature of image, position of image, everything will be changed. So you have to use the sign convention in a करेक्ट ऑर्डर, जो जिसका मैंने एक लाइन में कॉन्सेप्ट दिया, बहुत सारे बुक में बहुत सारी डिफरेंट डिफरेंट एस्पेक्ट आपको बता रही होती हैं, जो कि थोड़ी सी समझने में करके प्रॉब्लम्स होती है, बट मैंने बस एक लाइन में कॉन्सेप्ट लिख दिया, आपने उसको आपने बस फॉलो करनी है कि इंसिडेंट रे के डायरेक्शन में आपने पॉजिटिव डायरेक्शन लेना है, उसके जो भी अपोजिट रहे उसको नेगेटिव डायरेक्शन कंसिडर करनी है, right? I hope this concept will be clear to you. Now I'm again telling about the mirror formula. So the mirror formula here is actually, we have like a formula or actually relation between the object distance from mirror, object distance from pole, and image distance from pole, and the focal length. And the relation is actually 1 by focal length is equal to 1 by u plus 1 by v, which is actually 1 by the distance of object from pole plus 1 by a distance of image from pole. Okay, so now how to derive this formula? Because I'm just, whenever I give you the formula, so its derivation is also important. So what I'm trying to say is, let us suppose this there is a real object I'm considering for the concave mirror also. So you can also do it for the convex mirror as well. So the same concept is applying also there. So what I'm trying to do here is, I'm considering there is an alpha angle between the incident ray and the principal axis. Similarly, the beta angle is the line joining C and the A, and the gamma angle between the principal axis and the line joining image to the A. Now, from the property of triangle, which is actually the sum of the exterior angle is actually equal to the sum of two opposite interior angle. So I'm just in triangle OCA, I'm just writing the beta is equal to alpha plus theta, and in triangle CIA, I'm just writing the gamma is equal to beta plus theta. Now I'm just subtracting them both of the equations. So what we'll get, alpha minus beta is equal to beta minus gamma. So in this relation, we get alpha plus gamma is equal to 2 beta. Now what I'm trying to do here is, I'm gonna write the tan alpha, tan beta, and the tan gamma. So when I write the tan alpha, so the tan alpha is actually h by OP, where OP is actually the distance of object from the pole, which is actually in convention we write it as, or we denote it as u. So here it will be h by u. Same as tan beta, we denote it by r, so it will be h by r. And same for the gamma, so it will be tan gamma is equal to h by v. Now, we are actually, I'm again telling you, we derive all of the formula with the help of or for the paraxial ray, right? So in case of paraxial ray, the angle of incidence is less than 4 degree. So from property of trigonometric or the approximation of trigonometric identities, it will be like tan alpha is equal to alpha, tan beta is equal to beta, and tan gamma is equal to gamma. So here we can say alpha is equal to h by u, beta is equal to h by r, and gamma is equal to h by b. Mark my word, this formula is not valid for the marginal rays, where angle of incidence is greater than 4 degree. You have to apply the different concept there to solve the problem. So now here, when we write or when we substitute the things, where alpha is actually h by u, beta is actually h by r, and gamma is actually h by v. So when we eliminate the h, when we eliminate the term h, so what we will get? We'll get 1 by u plus 1 by v is equal to 2 by r. And so this is actually our mirror formula that we concluded above, and 2 by r is actually written as 1 by f, because we earlier derived that f is equal to r by 2. So 1 by u plus 1 by v is equal to 1 by f. So here we get v is equal to uf by u minus. So you can also write it in that term. So I hope today you all understand about the sign convention and the mirror formula, right? So these are the important concepts. So uh, that's all for today's. That's all for today's. In tomorrow's class, we are going to discuss about the rays diagram, right? Like how to like अगर कहाँ पे इमेज रखेंगे, मतलब कहाँ पे ऑब्जेक्ट रखी हुई होगी तो उसकी इमेज कहाँ बन रही होगी, है ना? एंड सम मोर कॉन्सेप्ट अबाउट द रे डायग्राम एंड ऑल. ओके, सो दैट्स ऑल फॉर टुडेज. थैंक यू.